All right, here's our tutorial on the second type of problem for our test, horizontal projectiles. Key that it's horizontal, the problem will tell you that the ball, the rock, the whatever is thrown horizontally. Key now is we're dealing with Y changes and X changes. Remember that ball is going to go down and out from the cliff. So we've got horizontal and vertical motion together. Key thing to remember, if it says horizontal, that means your starting Y velocity, okay, is 0. If we throw something perfectly horizontally, we haven't pushed it up or down at all. So that means our velocity to start, V0, in the Y. So the velocity to start, velocity at time 0 in the Y, is 0 meters a second. The acceleration in the Y is still due to gravity. That's negative 9.8 meters a second. When we have X, we know our starting velocity in the X is 5.6 meters a second because, again, we have that word horizontally. And acceleration in the X for projectiles, we are going to assume is 0 because gravity is only pulling up and down. It's not speeding the ball up horizontally, it's just pulling it downward. When you solve horizontal problems, find time. Okay? So, when you look at this, okay, we have an initial velocity in the Y, we have an acceleration in the Y, and we have one more piece of information. We know the change in the Y. We know the up and down distance is 12 meters. Look for the thing you know 3 pieces of information about. We know 3 pieces of information about the Y. That's where we start. So then we use the equation, okay? Delta Y equals 1/2 AT squared plus V0T, right? That's this equation, okay? Remember, it works for X and Y. Then when you solve it, again, we know to use this equation because we're looking for time. Always in these problems, just start trying to find time. So we know this equation isn't going to help us because there's no time. And we can't use this equation because we don't know a final velocity. So we have to use that middle one. So we have 12 meters equals 1/2 times negative 9.8 times t squared. Okay. Plus V0 is 0 times time. So this term goes away and our algebra gets a lot simpler. Okay. So 12 meters equals negative 4.9 t squared. And if you divide by 4.9 and take the square root, okay, and this is negative 12, I'm sorry, because it's moving downward, you're going to get a time equal to 1.56 seconds. Okay, so if we go back and look what it's asking for, how far from the base of the cliff does the ball land? Mr. Peterson, this didn't ask for time. Correct. But time helps us a lot to solve for these problems because time doesn't just work in X or Y. We can use time in both. So now we have the time for the X movement as well. So when you find the time in the Y, you've also found the time in the X. And the motion in the X is a little bit simpler to solve for because we don't have acceleration to deal with. So it's back to that formula of X equals VT plus X0, okay? Or distance equals speed times time. You've probably seen that in one of your previous science classes, but we can only use that in the X direction because the acceleration is 0. It's not speeding up in the X because gravity is only pulling downward in the Y. So if we solve for the distance, how far from the base of the cliff, that's the X direction, that's the horizontal. Distance equals the speed, 5.6 meters a second, times 1.56 seconds. And if you solve for that, you're going to get 8.76 meters. All right, let's do one more here. Do you see how this one's the same thing? We just have different starting pieces, but you're still solving for the same way with the same thing. Start by finding the time the ball is in the air. So it's horizontally. So we know our change in y equals 45 meters. And we know our change in x equals 50, and that should be meters, not feet. 50 meters, 50 meters, okay? Our acceleration in the y is still negative 9.8. Our acceleration in the x is still 0. And remember, horizontally tells us that the velocity in the y to start is 0. So the velocity is 0 and the y is 0. That's kind of the hidden piece of information that you've got to practice these to learn to recognize. All right, we have 3 things in the y. That tells us that's where we should start. So we have a change in placement. We have an initial velocity. We have an acceleration. We're looking for time. So that tells us it's got to be that middle equation because we don't have a final velocity. So we have to use that middle equation. If you've been in my class, it's the one I've listed first on the whiteboard, but it's still the same equation. So negative 45 meters because the ball's falling downward, okay, equals 1/2 times negative 9.8 t squared plus our initial velocity in the y is 0 times time. Again, yes, it has an initial velocity, but that's only in the horizontal. We didn't push it up or push it down at all. So then when you solve, multiply 9.8 times 1/2 and divide it over, you're going to end up with 9.18 equals t squared. So your time is going to be about 3.1 seconds. Okay? And then if you solve for that, okay, again, why does time help us so much? If we solve for time in the y, that means we have time in the x. It's the same time in the x and y. The distance in the x isn't the same as the y distance. The speed in the x isn't the same as the y. But when you solve for time, you have the other one. And again, x is a little simpler to solve for because we have no acceleration. So you can use distance equals speed times time. We have our x distance, which is 50 meters. Okay, and again, let's add feet in the problem, sorry. We're looking for our speed. Okay, I love touchscreens. Sorry, I keep getting the same thing happened in my last video. 50 meters times our speed, and the time is 3.1 seconds. So we're going to get a speed of 16.4 meters a second. Okay, so horizontal, key with these, if you see horizontal, your starting y is 0 velocity. Find time in x or y, whichever one you have 3 pieces of information to start with. Get time, apply it to the x or the y that you didn't start with. All right. One more video is on Canvas if you want to help with angled projectiles.